thought maybe like you couldn't hear me.
Okay, Kenneth, you can go ahead now to give us a summary of what we talked about on Tuesday.
Okay, so Tuesday we did an exercise that demonstrates how to manually build an AI agent loop without using any framework. That was what we that was what we touched on, and we followed by talking about orchestrations. What are orchestrations? Such as managing flow and coordinating of multiple steps automatically. So that is an orchestration. And we touched on okay, so like we touched on LangGraph and like we define it, but before I will talk about LangGraph, I think you showed a diagram which I think like that diagram like stick to me. Like I think like that diagram was about AI agents and like you simplifying it to be like models plus tools. So that's like diagram gave me a clear idea about what AI agents are, and I will like proceed by talking about LangGraph. So LangGraph is basically a framework that streamlines the creation and and the management of an AI system. That was how I um, grasped it in, and it has three key concepts, which are the state, the node, and the edges. So I simplified it to be the state. Basically, I think it keeps the information so that it can send it to anyone who basically and a request for it. So the state keeps information, it's like records it. Secondly, the node has the ability to update the state, and the node is things like the node is a function that also streamlines the workflow. And finally, will be the edge. The edge determines um, the steps to take. So the edge can be an if-else statement. So maybe if this condition is being met, we do this. If this condition is met, we take this route. So last week, that was what I was being able to grasp in, and that was the simple note that I was able to make. So I'm like, thank you.
Okay, that was a good attempt. Kenneth, look, does anybody have something to add? Anyone else who was here on Tuesday? No one? Okay, that's fine. We talked about the need for orchestrating agents. Okay, Daniel, please go ahead.
Hi, good evening, everybody.
Evening.
I just wanted to just add a little to what Kenneth said. I'll be kind of backtracking, but I think so that the topic was orchestration of AI agents, and then the understanding is that AI agents are able to handle multi-step autonomous tasks and with minimal human intervention as much as possible. And then the the agent is also usually goes through a loop or a cycle, which is the reason, act, and reflect loop. I mean, till whatever task you have given it is completed. So the orchestration is about how to coordinate this process or this cycle with the agents. And then LangGraph is that framework or that library that we are going to use to do the orchestration. So that's the list I just wanted to add to what Kenneth said.
Okay, that's a good one. I think I need to show Kenneth, this was the diagram we were talking about, right? Hello, Kenneth. Was this diagram that you were talking about the one currently showing?
Say yes, please. Yeah, this
Okay,
one.
so this just illustrates a simple agent, right? There are agents that have sub agents. So this was just a simple agent that has the LLM for reasoning, that has tools for action, and of course, there's the state and there's the custom loop, which is the um, orchestration itself. The loop performs the orchestration. Okay, so I think we'll get to what we have for today. We saw we tried to build an agent with a custom orchestration loop, and we identified the challenge where if the agent makes a mistake and the LLM identifies that mistake and tries to make a correction, the loop terminates because the termination condition is if there's no to call, take it that um, the intent has been achieved and provide the user with the message from the LLM. But sometimes that message is the LLM reasoning that, hey, I made a mistake and here's how I can sort it out. But when that happens, because it doesn't accompany that with the to call that makes the correction, the loop interprets it that hey, it's all done, the intent is achieved. And it was one of the things I asked you in the Slack channel, the thread. Well, we talked about it in class when I said you should try out that code and try to play around with it. I was asking you to try to see if you could improve this orchestration loop so that shortcoming is resolved. Was anybody able to get any success doing that?
Yeah, that was it.
Sorry, I
I
didn't
tried
get
to run
you.
the code, and it's um, so I found the shortcoming of the code, like based on the models that um, I use, like using Grok. Yeah. So like I realized that if you use a higher model, the accuracy of getting what like you need like might be instant. So like okay, so me comparing using I got like to realize that the smaller one finished earlier, but it skipped a particular step. But when I used the Llama 4, it took some time, but it was able to complete the steps, which and with the Llama 3 too, it told me that it is not sure of the answer that it is giving me. But for the attempting to execute the loop experience, that one I haven't like tried that yet. Probably as like we go on, I would I will pick that one up and try it.
Okay, sorry for that short break. I had to adjust my position to somewhere a bit more quiet. Okay, thank you very much for that, Kenneth. Was it Kenneth or Daniel that mentioned that they tried to? I think it was Kenneth. Oh, thank
Yes,
you for
Kenneth.
that. Yeah. Um, well, really, what you said was that you tried to use different models. That's fine. But what I was talking about is trying to fix um the orchestration loop such that it doesn't matter the model who- so that when the model realizes that it has made an error and it tries to fix that, um anyway, the essential thing is trying to fix that bug, that logic error that the loop terminates prematurely when the model tries to correct its errors. That was the thing. But it's something that everybody should try to see, try to fix that bug so that if the model realizes that it's made an error in the previous step and reasons, hey, I made an error, I should correct that, and these are the steps that I would take to do that. The loop shouldn't terminate. It should loop again to enable the model now call the tools, either call the correct tools or call them in the right sequence. I mean, if the LLM realizes its error and is trying to fix that, the orchestration loop shouldn't um, torpedo that effort or that intended effort by the LLM. That's something you should try to solve the orchestration loop. Okay, so we move ahead. Um, well, on Tuesday, I think this was where we ended, where I told you what LangGraph is. It's simply a library for simplifying this agent orchestration. The library is part of the LangChain ecosystem. So it's used for building stateful multi-actor LLM-based applications, and it makes use of directed graphs in the control flow. I think I mentioned, I believe I did, the core components of LangGraph include state nodes and edges. I think probably this was actually the diagram that Kenneth was referring to, not the one I pulled up earlier. Because I think he mentioned state node and edges. So that would be it. Now, edges can be either direct. A direct edge between two nodes is one that once if you have a direct edge between node A and node B, it means that whenever the agent's execution arrives at node A, the next node would definitely be node B. But if you have a conditional edge, it means that when you arrive at the beginning of that conditional edge, based on the conditions, you need to decide. There's more than one possible path at that edge. So which the exact path to be followed depends on the condition. And that's what Kenneth referred to as, was it Kenneth or Daniel that did that, referred to it as if else, something like that. So today we'll look at agentic design patterns, well, with LangGraph, because LangGraph is the library we'll be using primarily for building agents in this training. Of course, we'll use LangChain too, but for orchestration, we're going to use LangGraph. The patterns include React. We've talked about React earlier on in the training, right? So it's not something new to us, I believe. So essentially, in React, the concept is that the LLM, the agent reasons. Of course, that reasoning is done by the LLM component. It reasons about the user's intent, and then it takes some action. And it goes through a loop of reason, acts. Of course, it will typically, the action will typically be followed by some reflection, some observation. So it reasons and acts, and typically it will observe the results of its action and then reasons about them to decide whether it should take further action or just report and give the user the answer. So even that observation, it's tied up with some reasoning. So we could just summarize that as an iterative loop of reasoning followed by action. And then it continues to do that iteratively until the intent is achieved. And the flow in LangGraph will be from the LLM node to a conditional edge, and then from the conditional edge to a tool node. The conditional edge here is about deciding which tool should be called. And based on that decision, it moves with the node corresponding to that tool that the agent has decided should be the next node. And after the tool node, it goes to an LLM, back to the LLM node through a direct edge. And this is where the LLM reasons about the output of the tool call to decide whether it needs to do something else, maybe call another tool or call that same tool again, maybe with the same or different arguments. Or if it figures out that the intent has been achieved, it just gives the user the response. And the flow control is done through conditional edge checks if to determine whether the LLM output would be the final answer or a tool call, essentially reiterating what I talked about here in the LangGraph flow. Another pattern will be the reflection and self-correction pattern, which the goal is for an agent critiques its own output, and then, if necessary, it makes corrections to that output. So the objective really is about higher quality and correctness. So when the LLM critiques its output, it determines if that output does not meet certain correctness or quality thresholds, the LLM would try to improve the process or the output, as the case may be, so it can iteratively improve the output until it gets something that is of good quality that it can now provide to the user. The keynotes in this pattern would be the node for generating a draft, the node for critiquing that draft, and the node for refining that draft based on the critique. So it will still involve a cycle, an iterative cycle of moving from the draft generation node to the draft critique node to the draft refinement node, and so on. The flow logic in this case involves I've already mentioned this anyway. You have a conditional node from the draft critiquing node where it decides based on the critique results whether it will route to end, and if it determines that the output is of good enough quality, it ends the loop. But if it decides that there are still some improvement to be made, it will loop back to the draft refinement node for another iteration, and it continues that loop until it achieves satisfactory output quality, and then it can end the loop and provide the results to the user. Any questions so far? Okay, then, so we'll continue. And the next pattern we'll talk about is the hierarchical multi-agent system. Here, it's a pattern that involves multiple sub-agents, if I may use that term. You have a master router agent which analyzes the user's request and then decides on which is the most appropriate. This is supposed to be specialized agents. It's supposed to be past tense. So there is a master router agent and there are expert agents. The expert agents each has a specialty. Each one has an area where is specialized in. So when the user prompts the agent, the master router agent, well, in this case, when the user prompts the multi-agent system, in this case, the master router analyzes the user's request, that means the intent, and figures out which of the expert agents is the best suited to handle that request. Of course, it's possible that to adequately handle that request, it might entail the services, in this case, if I may use that term, of multiple expert agents. Maybe some in parallel, maybe sequential. You can think of the specialized agents like souped up tools that the master router agent uses to achieve the intent. So these are, typically are tools. We think of them as functions, but in this case, these are actually full-fledged agents that the master router could be said to be using as tools. So when it figures out which one to hand off the request to, it does that, and that particular expert does its job and provides the response, the results, which, if it's necessary to hand over to some other expert, the master router figures that out and goes on. So you have this iteration from master router analyzing what's the next thing to do when it figures and which expert agent is the best equipped to handle that next step, and it hands over to that expert agent to do its magic, and so on and so forth until the intent is achieved. Well, like I've already essentially mentioned the nodes, the master router, and the different experts, and the experts could be a research agent, a coding agent, a whatever agent, depending on exactly the capabilities that the multi-agent system is designed to have. In LangGraph, this can be implemented where the master router returns just exactly the way calling tools works. except that in this case, what the master router returns is the name of the expert node. Of course, there's a conditional edge that branches to the execution flow to the appropriate expert node based on the output from the master router. And then the request is routed to that expert to handle, or is a sub task in the overall task that has determined by master router's analysis. Then we have a sequential agent chain, which is simply like a linear flow where we have sequential execution from one component of the chain to another. Just think of it like when we have like the chains we built in LangChain, we have the
Sequential chain.
prompts. Yeah, I'm using an analogy now to describe what sequential chain is. When we build chains in LangChain, right, we'll have moved from a prompt to maybe an LLM, from LLM to an output parser, and so on. But in this case, it's actually agents that are in the chain, not simply components. So the agents form the components now. For example, you could have a sequential agent chain where a research agent, in this, you have a sequence of a research agent to a drafting agent to an editing agent. So let's assume you ask a question, the user gives the agent system a query, the research agent conducts the necessary research, gathers the necessary information that that would help address the user's query, and then execution passes to the drafting agent, which will draft a preliminary response to the user's query, after which the editing agent, you could, before the editing agent, you could have a critique agent first before editing, or the editing agent performs the critique function, and for drafting agent, that should be a single T, please. So the editing agent then edits that draft and produces the final polished response, which is now provided to the user. And this sequential agent chain can be implemented in LangGraph just by using direct edges between specialized agent nodes. So just like the hierarchical multi-agent system has specialized agent expert nodes, the sequential agent chain also has expert nodes. The only difference is that in the sequential agent chain, you are not most likely won't have a master router agent, since you don't have conditional edges. It's just a sequence, a predetermined sequence. Any questions so far? No question. Okay, we'll move ahead. Another design pattern would be human in the loop. Now, in the human in the loop system, you build into you build into the agent a mechanism that for critical actions, for sensitive actions, for costly actions, the agent pauses execution and waits for a human's review and for the human to give a go ahead before it can move on to execute such actions. But if the humans doesn't provide that approval, then it terminates or does whatever else. But the idea here is that there are certain actions that are too sensitive to just leave to an autonomous agent, or too, well, cost could make something more sensitive. So you don't want to leave such sensitive operations to an agent to handle autonomously. And so you leave the agent just prepares, makes all the necessary preparations for that action or operation, and then you wait for a human to give the go ahead, wait for a human to approve the actual execution of that action. And the mechanism is that the agent can persist its state. So when it gets to such nodes, when it gets to waiting nodes, it persists its state and then it pauses execution and waits for human approval or otherwise. So it's the approval of the human in this case or otherwise that determines what next would happen. There's quite a bit of typos in today's slides. My apologies about that. And the flow is like this. The agent generates a proposal. What are the actions it proposes to take? And where that proposal involves some sensitive action, when there will be a waiting node at that such that before it can undertake such an action that involves such excessive action, it waits for an external signal from the user. This is supposed to be a T. It waits for an external signal from the user, and then there's a conditional edge that routes to the next action based on the signal that was provided by the user. For example, it could be that there are multiple courses of action apart from take the action or don't take the action. There could be multiple possible courses of action. The important thing here is that the agent does not autonomously decide on what course of action to do at this wait node. It waits for a human to take that decision. And so that is essentially how the human in the loop design pattern for AI agents works. Any questions so far? Okay, that's fine, Adobe. It's okay. If nobody has a question, myself, I have a couple of questions. The first question would be, I would like for you to give us, any of you anyway, to give us a concrete example of a scenario or a task or intents that would require, well, it wouldn't be intent now, a kind of workflow or scenario or kind of tasks that are best where the human in the loop pattern is best suited for. A concrete example of where the human in the loop pattern would be the best to use. Of course, you could use more than one pattern in a given agent, depending on exactly what your use case is. Yeah, that's the time for use case. So who can give us a concrete use case that where the human in the loop pattern best fits in? Lara, I saw that you unmuted yourself. Did you wanted to speak?
Okay, so I didn't commit it to GitHub yet. I was just thinking randomly, sir. Though it's not a use case that has come to my head before, but random thinking, I understand that it will be something that is very critical that should not be left to a machine to decide. For instance, a use case I'm thinking is maybe there's a war, ongoing war, and technology is being deployed, and maybe a drone is to be released to destroy a particular enemy location, and if the agent has been able to fine tune the location by maybe longitude or latitude or whatever, then requiring the controller or the commander of the troop to give a final go ahead that okay, that's the location before discharging the missile to the precise location. Just a random thought, sir.
Okay, in this case, it's the action affects human life, right? So that's quite a sensitive
Yes, sir.
that's quite a sensitive use case, and so a human loop would be the best for that. Some persons would not like that example of what do you call it?
Use case. Use case.
Yeah, use case
But if we are working with
involving
NASA or CIA, that may be our call.
yeah use of AI in warfare and so on is quite a sensitive topic anyway. Some persons don't like that. Some persons are seriously against that anyway. Okay, so thank you. That's a very valid example, Larry. So, Daniel, could you give us a concrete example, a concrete use case? Everybody here is going to give us an example use case, where the human in the loop design pattern um, is works best or is really um, appropriate. Daniel, are you there?
Yes, I am.
So give us an example.
Okay, so I'm trying to get an example that is in the field that I'm working right now, which is
Okay,
facilities management.
so let's give you a few minutes to think about that. Kenneth, would
Okay.
you give us one?
Okay, so um, let's think about an HR agent who is
Okay.
supposed to maybe assigned tasks or roles within a particular company, or even let's say just like make a payment through the various workers
Okay.
within a specific um,
So like
organization.
like like a
So
payroll agent.
yes.
Okay.
So it should be very um, specific and have concrete information so that it doesn't make any actions which goes contrary beyond what it has been set to be built upon. So that will be my 2 cents on that one at the moment.
Oh, okay. Can you give us an example workflow for such an agent and tell us at which point the wait node should be implemented, at which point in that workflow?
Okay, so for instance, back to the payment step. So the agent should be able to recognize the specific worker, because maybe each worker takes a different pay as compared to each person. So it should be able to assign the pay of a specific worker, maybe based on his rank, so that like it doesn't make mistakes sending it to the wrong person. So that was how I got to the question you asked. I don't know if I'm going off topic or maybe
You're not
yeah.
off topic, but I think you didn't really get me. I'm saying for this, without for payroll, there's a typical workflow, right? Um,
Yeah.
Whatever the metrics are for calculating pay is done. Whatever is done, and then the workers are paid. So what I'm asking, give us that workflow that typically the agent will most likely follow the same or a similar workflow to how it's done without an agent, right? So I'm saying give us the typical workflow that agent will follow. You do this first, do this second, do this third, and do this fourth, and so on. And then after you've outlined the steps in that workflow, which may also entail some decision points where it could take either of two or more actions based on some conditional checks. But just give us the workflow and then tell us at which point in this workflow, of course, we know it's an example. At which point in this example workflow that you've outlined would a wait node be implemented? That's at which point in this workflow should the agent pause execution and wait for the human approval? But first, you have to give us the workflow before you tell us where the agent should pause execution.
Okay, so the workflow that I'm currently am I thinking about is so gets the workers' names, gets their ranks, um, check the number of days that they came to work if they are supposed to be okay. So check the number of days that they came to work. If they miss a particular, if they miss an amount of days, so maybe if they miss 3 days or 2 days, deduct this amount. If they came throughout, their you pay their salary due them. So I think I have listed three steps, and finally, yeah, yeah, I think that's that's what I
So
can come up with.
at which of these steps should the wait node
Okay,
be implemented?
so the final output, because it has to check to ensure that all the boxes has been ticked before it proceeds to make a particular action.
Okay, the final output here being where it deducts some amount based on the days the worker misses, or where it actually makes the payments, which of them?
So final output here is it confirms the name, it confirms the rank, it confirms the number of days that the worker was present, and it goes ahead to make the action.
Yeah, so we've essentially just outlined the whole steps that you mentioned. At which step should it pause for human approval?
So a step where it should pause
Yeah.
um, will will have to be checking the name, the rank, because when you get there,
Okay.
like you need to take your time, because like there might be people having the same names, which could confuse the agent. So there could be an extra tool designed to check maybe specific, maybe the index of a particular worker to ensure that it is not assigning the wrong um, salary to the next person. Because maybe if there is someone also called like Kenneth Danso, and there is also somebody called that same name. The only differential here might be we using the ID of both workers. So when it gets there, it needs to take its time. So like when you get to the names, take its time. Okay, fine. Now like we can move to the next step. When it also gets to the point of verifying how consistent the work has been, attendance, I think the agent should also take its time and make sure everything is set
I
before it
guess
goes ahead to make.
I guess you I guess maybe you don't actually understand fully Well, what you're just saying is that the agent needs to be careful. The agent needs to be such that it avoids mistakes as much as possible. That's what I understand from what you've said. But the question is, at which point, of course, it's a given that your agent needs to be as accurate as possible, right? But the question here is, at which point must the agent wait for human approval? Which of these steps is so critical that you typically wouldn't leave it to the agent to just make a decision autonomously and take the action autonomously without human approval?
Oh, at the point of like releasing the funds.
Yeah, that's right. I agree with that. So it's really about a critical point, is a sensitive action. The agent should the the point just before a sensitive action is the point where, excuse me, you should implement the wait node, so that at that point it has weight, of course, maintaining its keeping its state. Then it waits for the human input to determine what action, whether I should go ahead with the action or not. Okay, that's fine. Daniel,
Thank you.
have you figured out the use case you want to
Yes, I
tell us
have.
about? Okay, please go ahead.
Okay. So I'm looking at an agent that assists the facilities maintenance team.
Okay.
I mean, this is drawn from the previous assignments that you gave us.
Okay.
So in facilities management, usually the manager is managing properties,
Okay.
and then usually they contact the manager whenever there's an issue,
Okay.
and issues vary from electrical, plumbing, I mean, minor repairs and all of that. So I'm looking at an agent that has oversight or has access to the maintenance team's email.
Okay.
So the workflow is such that the user of a facility sends an email, maybe making a report about an air conditioner that is faulty
Okay.
in a server room of the branch. So
Okay.
the agent is able to extract the information from the email to see that, okay, this is a server room and then the air conditioner is faulty. So then it is going to be able to classify that report as being critical or urgent. So the next step is to be able to engage a vendor who is going to go and work on the air conditioner.
All right.
So I think this is the point that the agent would have to wait for the human to take that action. That action could be a call to the vendor or an email to a vendor or maybe a work order that will generate to send to the vendor. But the human must come in to ensure that it's not going to, because once you engage a vendor and he goes to resolve the issue, you come with an invoice. So the question is, are you ready for that cost at that time? Are you prepared to repair, or maybe you have plans to replace that particular AC? So that is where the human must come in to take that decision.
Okay. That's a good one. So Sarah, you what use case do you have for us?
Okay, so my use case will be like a lead generation workflow. It will start
You
by
said lead
let's
generation.
yes.
Okay. Got it.
So it simply start by first, let's say, scraping some potential clients on LinkedIn, like their usernames and websites. Then the next will be an LLM processing that info by searching web for more details on the companies. And that's where the waiting node will come in. Human loop will be required to check if the company details found are suitable for kind of audience targeting. Hope I'm making sense.
Okay, so essentially, if the LLM just prepares everything, proposes a lead, and then waits for a human to okay that.
And it goes on. So after like a verification process, the next flow will be an LLM generating like a pitch copy for those companies and another waiting node for that to review the copies. That's what I could confirm.
Okay. Okay, that's fine. So essentially, it's ensuring that what the LLM generates actually is suitable for just
The target
avoid,
audience.
yeah, yeah, yeah.
Yes,
Just ensuring that there's no faux pas from the LLM.
yes, yeah.
That's good. All right, that was quite good. There was someone else that joined the call, but the person has dropped off. Okay, that's fine. So, okay, let's talk about one more of these one more of these one more of these patterns, right? We talk about let's talk about the reflection and self-correction. What use case we think that reflection and self-correction would be suitable for? Anybody can. Or let's say it this way. For each of us that talked, the four of you that talked, the other which other pattern apart from human in the loop from these ones, sequential agent chain, hierarchical multi-agent system, reflection and self-correction, and react, which other one of these patterns would still be suitable in the use case that you mentioned, apart from human in the loop? And why? What makes this pattern suitable? What do you think makes this pattern suitable? The four of you will speak, so anyone can start.
Okay, so
What's the question again, sir?
I will
Okay.
start with. Oh, sorry,
Okay.
bro.
Let me repeat the question. Then Kenneth, you start. You've all mentioned use cases where the human in the loop pattern is applicable, right? Now we mentioned some other patterns. The other patterns we mentioned were React, reflection and self-correction, hierarchical multi-agent system, and sequential agent chain. Now, I'm saying apart from human in the loop, which each of the scenarios you mentioned, each of the use cases you mentioned is human in the loop is stable for is actually applicable in that use case. Which other of these patterns is also applicable in the use case that you mentioned? And why is this pattern applicable in that use case? So, Kenneth, go ahead.
Okay, so say I would pick um, reflection and self correction,
Okay,
and
why?
I'm picking that because um, using the name example, for instance,
Yeah.
whereby two users have the same name, and um, and the agent um, picks one ahead, or maybe tries to confuse the specific worker that it intends to sends a particular page to, during that process, the agent can reflect and recheck like the names again, or use the index before it moves to the human like intervention steps. So this is this is um, this is where I will use the reflection and self correction.
Okay, but if there's already an index for disambiguation of names to
Hmm.
solve this issue where you could have multiple persons with the exact same name, why would the agent not use that index in the first place? Why would you wait for a reflection step to cross check? Why not use that index ab initio to avoid making a mistake?
Mm, so I think that probably, so let's say maybe if that logic is not being implemented within the code base.
Mind you, I'm not saying that your answer is wrong. What I'm saying is why, if there's already a mechanism for avoiding that problem
Mm,
or avoiding that mistake, why
mm.
not implement it ab initio? Why wait? Why provide that make it so easy for that mistake to be made so that you need a reflection step to correct it when you could have avoided the mistake in the first place? I'm not saying that a reflection step using reflection and self correction in this case
Self correction.
is not
Mm.
valid. I'm just saying the reason you gave for that. Why not solve that issue ab initio?
Hmm. Mm. I think I'm black out there. So I think at the moment, like that's what is like popping in my mind
Okay, so
currently.
maybe
So
reflect on that a bit more. Daniel, go ahead.
I wanted to like support Kenneth a bit.
Sure, that's fine.
If you think about like the stuff list, like say an Excel sheet or like a database, like you're saying, it will have an index for each stuff. So it's like an ID number. So I think once you feed that database to once the user or the HR person confirms that that is the latest data that is available. Once the LLM accesses it, I think like you are good to go. You don't need to have it, I mean, reason and reflect over it again because the index will do everything. So then, like, you can be 100% sure they won't make a mistake and pick a different, a different stuff. At least that's how I see it.
Okay, that's a good one. But also it's possible for to apply the reflection and self-correction pattern before going to um the weight node. For example, the LLM has performed the payroll calculations and all that, and then it cross-checks its calculations to ensure that everything is correct before it now waits, okay, for the human to say, oh yeah, I concur with what you have and go ahead.
Gotcha.
That's why I said it's still having using the pattern is still valid. I mean, cross-checking, that's typically how you for such sensitive calculations, you will typically cross-check your work. So having the LLM cross-check its work is not a bad thing. You could even have a separate um, agent do that cross-checking. You have an agent that is generating the payroll and another that is cross-checking the calculations. In this case, now you have a well, I say like an accountant agent and an auditor agent So something like that. Now, in that case, you're using a different kind of pattern now, as the case may be, whether it's a sequential agent chain or hierarchical multi-agent chain, however you decide to work that out. What do you guys think?
Agreed. I agree.
Okay. So, Daniel, would you like to tell us about your one? What other patterns would work for your use case?
I think I'll go with the sequential agent chain. I think my workflow is a bit straightforward. I think so. If we have like an email extraction agent, one that has access to the emails and can extract the issues that are reported, from the emails. And then one agent that will do the classification because it has been trained, very well on, let's say, facilities management protocols. I'm thinking about another agent. I don't know if that can be added to the classification one, but another agent that has like the history of, let's say, for all equipment, generators, air conditioners, AVR, CPSs, whatever. It has the history of the repairs that have gone on, parts that have been replaced. All that history is there.
Okay, so
Then,
we can solve that by context, right? Memory, using memory. So
okay,
some context memory that each agent can access.
can access.
We may not necessarily need a separate agent for that.
Okay. Okay.
Okay,
Then,
that's good. You have more?
so I think the last one might be, so once we decide on what to do, you have to prepare an internal memo that would seek approval to get the job done. So then maybe we'll have another agent to prepare a memo for approval, and then the work can be executed. So
Okay,
that's
well,
it for my end.
that process of preparing a memo is like seeking approval, right? But if we're already using human in the loop, wouldn't that solve that memo part? Because if all the memo does is just to seek approval, then the human in the loop also provides that approval. Wouldn't that solve that?
So the human in the loop, yes. Okay, so maybe that step will come after the human in the loop because the okay, for me personally, I think it's a bit boring to put together an internal memo requesting for approval for it to be done. So that agent can draft and then maybe just edit. So the memo comes in like a Word form. It's on a Word document that you print out and then you seek approval for it to be
Yeah,
done.
yeah, I understand that. Okay, I guess I was thinking differently. In this case, you are seeing the human in the loop as just to confirming, yeah, the agents triage that there's actually this problem and we need to engage an external vendor to come and
To
carry
come
out the
and work on
maintenance
it.
operation is necessary. Okay, I was actually thinking my thinking was, oh, the human in the loop is to say, oh, yeah, go ahead, engage the vendor.
The
But I
vendor.
guess you're thinking of, okay, it's fine to now seek approval from management before we go ahead to engage. Yeah, that makes sense. Yeah. What one thing, important thing I think I need to mention it here is that for you to build an agent to handle the business case, whatever use case, you need to understand the current process that is taken to handle that use case. So the essence of the agent is to automate the process, or at least either fully or to some extent. So you need to understand the process. Yes, in the course of building the agent, you may need to that process may need to be modified, because if you identify some inefficiencies in that process, it's good to um, adjust that before you build the agent. But those things that are inefficiencies may also have some business value, right? The key thing I'm saying here is that for you to build an agent for a process, you need to first understand that process. Because the agent will not live in isolation. The agent has to serve the business case.
Agreed.
Okay, Olanrewaju, your turn now.
Sir, I've been thinking about my use case that you said is subject to, I mean, some people are averse to it. So, but if I may start with that concept, I think apart from the human in the loop, the reflection and self-correction may be a vital use also. And my
Why?
reason for my reason for saying so is, for instance, like I mentioned, maybe because location is a very vital parameter in that decision making. So if the drone has zeroed in or locked in a particular uh, location by latitude and longitude or the precision to any precision level, then I don't know. Maybe it's possible. Maybe the location was obtained via an API to maybe Google Map, or I don't know. Maybe there are other geolocation functions. So there may be a need before the human in the loop. There may be a need for the LLM itself or the agent rather to confirm if the location is actually correct. Maybe to check to parameterize or compare the parameters of the location from the API with Google. Maybe there's another way of checking, just to cross check to be sure, because for it the intention is to lock in and release drone to a particular location stated with a stated longitude and latitude, so to say. So to be sure that he's not missing the location, apart from the first reading it obtains from maybe an API or another agent giving a location, maybe there could be another way, which is the reflection aspect, the self-reflection and correction here, to confirm if it is true before engaging, and they're only seeking approval from the human.
Okay, so
That's the
essentially, it's for the agent to try to cross-check the proposal that is waiting for the human to confirm, to consider that it's correct and make any necessary adjustments before getting to the wait node where the human will now either approve or otherwise the proposal from the LLM. Am I correct?
yes, sir.
Okay,
Yes, sir.
that's good. But there's one pattern that you didn't mention, even though when you were trying to describe this one, you mentioned it. You mentioned maybe the location is obtained from an API and so on.
Yes.
Is that not the use of a tool? Does that not point to the React pattern?
Okay. To reason. Okay. Actually, what I was saying is, okay, given the plan given to it, or rather the target, the task given to it, that, or maybe a subtask, that this is the location precisely you are going to. Yes, the tool will be built in it. A tool will be
Even the
available to.
release of the drone, is that not some external capability that requires a tool to be effected?
Okay. Yeah, I think that's the aspect that will have to wait before the execution.
Yeah, even
But
when the user gives the approval for the LLM, go ahead and release the drone. Doesn't the LLM need to call a tool for that drone to
yes,
be released? So is that means you still need the React pattern?
okay, yes, to act.
Yeah, because it reasons it. If it proposes, say we need to release a drone to so and so place, the human approves, go ahead. It needs to figure out which tool to call for the release of that drone. So it has to reason, what tool do I call to release this drone? I've gotten approval to release, and then it calls to. So that's React. So essentially, you've mentioned 3 different patterns in this same use case, in this same agent. So one clear thing is that you can use multiple patterns in the same agent, but it has to be relevant to your use case. Sarah, your turn now.
Yes, I think for mine would be the sequential agent chain,
Okay.
like in the while waiting for the waiting node to the first process to approve the companies. You see, the LLM is waiting for the human node to confirm the company details, and in the next process also to review the pitching copy before it, like maybe if it is sending out emails and so on.
Okay, so because your use case essentially involves linear process, sequential and linear process, that it
Yes.
lends itself to the sequential agent chain. That's a good one. But do you also think that the React pattern is also applicable here? You mentioned scraping, web scraping, I think, scraping information from maybe LinkedIn or something. Wouldn't that require the use of a tool?
Yeah, it does. It does an API calling, yes.
So React comes in here too.
All right.
Okay, trust. Have you been able to get adequate context? And you didn't join us in time. Have you been able to get adequate context from the discussion so far to make a contribution yourself? Trust, are you there? Okay, no response. So we move ahead. Um, so at
Sorry,
this
I have a
point, we
question,
are
sir.
okay. Please go ahead.
Would it therefore mean that apart from having the human in the loop, does it mean that everyone must end with React because action may be the last stage?
If it involves the use of tools, React is the pattern that involves reasoning and acting. So it involves taking some action. The action in this case is using tools. Then React comes in.
That means React must be in every or the very end.
Well, not necessarily. It's not just about using tools. Remember, there's a cycle: reason, act, reason, act. If it involves something like that, then it's React.
All right. Thank you, sir.
If you have just a let's say you have a writing agent, right? You give it a prompt, and then you decide to use the reflection and self-correction pattern, for example. Then you don't need React. You just say, write me a poem of so and so, or write me a story of so and so. It just drafts the story, reviews it, and comes up with a final copy. It doesn't need a tool in that case, so React doesn't come in.
Yes, thanks so much, sir.
Assuming that's the workflow you have for your agent. You're welcome. So at this point, we are going to look at some code. Um, I built a simple React agent using LangGraph. It's the same agent that we actually had in the last class, right? Where we implemented the execution loop without LangGraph. So I'll show you an example of that same agent now built with LangGraph. So we see the difference. I'll stop sharing a bit so I can share my IDE instead. Please let me know if you can see my screen. Can you see my screen yet?
Yes, your screen is visible.
Okay. So this is the same agent we built in the last class, or we looked at in the last class. In the last class, we implemented this agent, the orchestration loop. We implemented it without LangGraph. So in today's code, I've implemented that same agent, but now using LangGraph. So this beginning part is essentially the same as the code we had on Tuesday. It only starts becoming different at this point, at line 102, where we define the state object. We define the agent state as a typed dict class, and here it has two fields. The first is messages, which is essentially the chat history that we had in the code from Tuesday. So this message just keeps track of the chat history. And then we have this tools info DOM, which the tools info DOM contains information about the tools. It's supposed to provide values to fill in the tools placeholder of the prompt template. That's just why we have that tools info DOM. And we generate that information using the get tools info function that we defined a few weeks ago. Yeah. So the agent state class here represents the state of the agent. The message is defined as an annotated list, because at each step, it's updated automatically by LangGraph. And so that's why we're using the add operator. We keep adding to that list, appending using the add operator. Okay. Now we've defined a run LLM node function, which takes the state as its only input. This will just execute the LLM node of the agent. And what it does is just it extracts the message from the state and extracts the tools info from the state. And I added this here, this print state before running LLM node, just for you to be able to see how the state changes as the agent execution proceeds at different steps of the agent execution. So this will just print out the state before it calls the LLM. But I mean, it's not necessary. It's just here for you to be able to visualize how the state changes as the agent execution progresses. Now it calls the LLM with the chat history and the tools with values for those placeholders in the prompt template, and it returns the result. Now it's supposed to return, the return type is agent state, right? It's returning a dictionary containing just the messages key, and the value is the result. Now, the reason this works is that LangGraph rather, it expects just you can provide the full you can provide a dictionary giving the full including tools dump, but tools info dump really doesn't change. What changes is messages. And so when you give it this dictionary, and remember that messages is an annotated list. LangGraph is going to automatically update the messages component, the messages field of the agent state with the update. So you just need to provide the incremental updates to the state. That's just what you need to provide, and LangChain or LangGraph will make the necessary updates, and that updated state will be passed to the next node in the execution sequence. Then we have the execute tools node function, which executes a tools node. Remember, this is a React agent, right? There's the LLM reasoning engine, and then there are tools. Here, what it does, it extracts the last message from state, the messages field of state. That last message is essentially what it needs to happen. Now, this is doing the work of the code in the previous Tuesday's code, where we pass the two call requests of the LLM, and then we execute we call those functions. So here, the last message in the messages field of the state is the response from the LLM when it was invoked. And it's from that element that we're going to extract the two calls, which is what is done here. And then we define the two messages list like we did previously. I've also added this here so that you can see what the state is after, before executing the tools, which is after calling the LLM. So you see that the state was actually updated by LangGraph. And then just like we did in the code from Tuesday, we passed the two calls from the LLM's to response, and for each tool we execute it. So if the tool name is in our tool map, remember the tool map we had from Tuesday's code, it means that it's a valid tool that the LLM has access to. Then we try to execute that tool, just similarly to what we did on Tuesday, and then we append the output from that tool to our two messages list. Of course, we create the two message object, and that is what we append to two messages. At the end, we are going to return two messages. We return the incremental update that's going to be made to the state, which is a dictionary of messages, and the value will be that two messages list. Remember that the annotated list that message is the LangGraph is going to keep adding whatever we return to it to update the state. So when you add two lists, essentially what you're doing is an append. But if the execution was not successful, just like we had in Tuesday's code, the tool message that is going to append will just have information about that error. The next will be now to route the routing of execution. So here, what this does is it checks the last message, and then it of course, I also added this to print out the state to see how the state updates at each point. And then it decides, should it terminate the execution or should it go ahead probably by calling a tool? Now, if it checks that there are two calls in the last message in state, if there are two calls, then it means that it's supposed to call a tool, so it returns call to. If there's no two calls there, that means the intent has been achieved, so the LLM should return the final response to the user. It returns end. So we have these three functions, and we are now going to use those three functions to define our agent. We define the agent using the state graph object from LangGraph, which we imported we imported it here from LangGraph.graph. We imported state graph and end. End is actually the end node. There's also a start node, which is predefined. Start and end are predefined in LangGraph. So we define our agent graph as state graph. Remember, we mentioned that LangGraph is a graph-based agent orchestration library. And then we add the nodes. The two nodes we have is LLM and tools. So we add those nodes to the agent graph. And then we set the LLM node as the entry point. That means once you invoke that agent, it's going to start from the LLM node. Then we add edges. We add a direct edge between tools and LLM. Remember, when we were talking about React, we said after tools, there's a direct edge to the LLM. So once after tools are executed, it must go back to the LLM for the LLM to observe the tool output and then reason on whether it's supposed to call another tool or even the same tool with maybe the same or different arguments, or it's supposed to return a response to the user. So this edge represents that direct edge between observation and thought, between the tools node and the LLM node. And then there's the conditional edge, which is where when after the LLM node, what next should be done? Would it be to call a tool or to return the result to the user? And that's what this conditional edge represents. It's a conditional edge between the LLM on one point and then conditionally either calling tools or ending the agent execution loop. So it's a conditional edge between the LLM and route next step. Remember, route next step is the function we define for routing the next step of the agent. So once from the LLM node, we go to route next step as the next node. That will now, based on its logic, is either going to output call tool or end. If it outputs call tool, then we call tools. Remember, we have a node that we defined as tools here. So if the conditional edge outputs tools, then the tools node becomes the next node. But if it outputs end, then the end node becomes the next node, in which case the LLM will just output the response to the user. And after defining the agent graph, we compile that graph, which gets it ready for execution. And then we invoke the graph. We specify location and we specify the user prompt, which we are going to pass as we're going to use to compose the initial state of the agent. Now, before when we were just building LLM-based applications, not essentially agents, when we built chains, we had the prompt template with the LLM as the next step in the chain and our output parser. In this case, we are not just invoking with the prompt values of the prompt template. It is the state that we are passing to the agent. And that's why we are defining the initial state, which comprises, for messages, we have that initial message, which is the user prompt, of course, as a human message. If you remember our definition of agent state, let me get here. Messages is an annotated list of base message sequence. So whether it's a human message, an AI message, or a tool message, that's fine. Any of these can be appended to the messages list. So to start, we are appending a human message to it. And so this becomes the initial state that will be passed when invoking the agent. And here we invoke the agent and we get the agent runs and gives us the result, which we print out. So I'm going to run this script and we'll see what result it gives us for prior. The query here is what's the current weather and time in prior? And based on the tools we defined, it's going to give us the temperature. Of course, it's a simulation. It gives a random temperature value, and then it gives us the actual current local time in prior. That one is actually be the current local time in prior, but the temperature will just use a simulation using a random temperature value. So we execute. I had set use grok as true, so it's going to use a model from grok. Now, if you remember that I put statements to print out I made calls to print out the state at different steps in the execution flow. This is the state before running the LLM node. And see here, it has that initial state, which is the human message, what's the current weather and time in prior. And that's the messages list ends here. The next is tool info dump, which is the next field in the agent state class, agent state objects. And that's every other thing here is about that tools info. Now, before routing to the next node, this is the next. We have the state. You see that the state here, compare the state before running the LLM node and the state before routing to the next node. Remember that the execution is from LLM, it has to route a conditional edge, deciding whether it's going to call a tool or it's going to end. So that is where we are here now. And let's look at the state. You see that the state has been updated with the AI message. Apart from the human message, which is the original user prompt, we'll see that the AI message has been appended to the messages field of the state. LangGraph updated that automatically, and it contains information about the tool calls, what tool was called, and what parameters were used. These actual tool calls anyway. You see that it was updated. It's actually the state object now is actually longer than before routing to the next node. Of course, it's routing to a tool call, and so the tools were executed. And this is the state before running the tools, which will typically be about the same as before routing to that. And then it calls the get offset from UTC tool, which is on -1 as the offset for prior. Next, it routes to the next tool, which will be get local date time, and it gives you the local date time. I think the next would be probably routing to, when did it route to get them weather? Okay, probably I think it made a parallel call. Yes, I missed that. It made a parallel call. It called get location temperature and get offset from UTC in parallel. And these were the values we returned. It got 15.9 Celsius for temperature and -1 as the offset from UTC for prior. And after getting the local time in prior, the next time, given that the LLM has figured out that it doesn't need to call any tool again, so the routing returns end. and the agent now returns the final response to the user. The current temperature in prior is 15.9 degrees Celsius. The current local time in prior is this. Now, I'm going to go back to the agent we built on Tuesday and also execute it. So you see that the response format is similar. I'll use Grok because that's faster. Oh. Yeah, the current time, okay, this is for Kigali. I think I should change, but it's essentially the same. You can change that to prior. Yeah, the current temperature in prior is this, and the current time is this. I believe it's the same. Are we using the same model? Okay. Let me see whether that's the same model in uh, no, you should use the same model here. Okay. Current temperature in prior is 30.3 degrees, and the current time. Okay, sorry about that. Somebody came calling. Even though I know that the agent hallucinated because I know that this Llama 3.370B, it tends to, well, I didn't check, but I believe it does because that was one issue. It tends to call the three in parallel. But the major thing here is to see that it gives you exactly the same as when whether you're using the LangChain LangGraph based agent or the agent that we built without LangGraph. That's basically what I have for you for today. Like I asked you on Tuesday, I would encourage you to run this code yourself, try to run it with different models, and try to run it with Olama models, Grok models, any other provider. Try to make different adjustments for different locations and so on, and try to compare this with the performance with the one we built using a custom loop that we didn't use LangGraph. And then let's try to see whether that challenge we had, where if the model realizes that it made a mistake and tries to correct it, does the loop terminate prematurely? Let's see whether that bug we had with the non-LangGraph based orchestration loop, whether we still have that with the LangGraph orchestration loop. Let's continue that discussion on what's the name? Slack is what's coming on Discord. I'm going to make the code I posted there on Discord. I'm going to also make it a thread so that we continue that discussion in that thread. Does anybody have any questions for me? Are we there?
Yes, sir. No question from my side, sir.
Okay. Yeah. Oh, okay. That means nobody has any question. All right. Thank you very much. It's now, gentlemen, the ladies have all dropped off. So please try to run the code and try to, if you can, try to start building agents for different use cases that you can think. Let's try doing simple ones, try to play around with them and so on. And then we'll keep making them more complex as we go, hopefully, so that by the end of the training, we will be able to, given a specific business need use case, build an agent, either as a fully autonomous or as a partially autonomous agent to add value in that use case. Okay, then I think we can call it a night since there's no further question. See you all.
All right.
We don't have any promotion task for this week, so use the time to, if you haven't already submitted your stage 3 task, use time to work on it. For those who are still in other states, I'll try before the weekend runs out to grade your submission so that you can work on your stage 3 task. Good night, ladies and gentlemen.
Good night, sir. Thank you, sir.